So my name's Nick Smith. I work for Talasea Security. Actually, there's some pictures of our hardware security modules earlier. I'm not going to be talking about encryption today as I normally would. I'm going to talk about securing microservices, specifically in a Kubernetes context. So some of the other work I do on behalf of Talasea Security is I'm a member of something called the Istio Security Working Group. Istio is a service mesh for Kubernetes. This is going to be quite fast. We're not going to go into too much detail just because we've not got enough time. So I like to start with a warning. All the tools we talk about today, and actually over the last 2 days, they're not silver bullets. Kubernetes, Istio, all the other tools that we've spoken about aren't going to make your world better on their own. You have to do a lot of the work yourself. A lot of these measures are defense in depth, and you've got to remember security is all about context. It's where you deploy your mitigations, and you have to understand that your mitigations match your context. Okay, so I think the last speaker asked how many people are using Kubernetes. How many are using Kubernetes in production? And is anyone using Istio? Does anyone know what Istio is? Fantastic. Right. So let's have a very quick primer on what we think microservices are, or from my opinion, what microservices are. So currently, a lot of development is focused at microservices, and there's a number of reasons for that. So what is a microservice? It's something, it sits alone, it stands alone. It's a small piece of functionality that has been derived from a bigger function, a bigger service. Microservices tend to cooperate, so to be able to use some part of a website, it may be a number of microservices cooperating to provide that functionality. Most modern microservices are being built on top of containers and on top of Kubernetes-like deployments. Now, what is interesting about this is we can dynamically compose products and services at runtime from a number of component parts. Additionally, and interestingly, from an operations standpoint, it allows us to develop code and solutions in more autonomous fashion. So what do we mean by that? We mean we can have a number of agile teams, each of which may own a set of microservices which form some higher function. So that all sounds good, but from a security perspective, that brings some challenges. So when we decompose our solution, we start to lose the holistic view. So how do we reason about the security of our solution as a whole? Because it's no good just understanding, is each of my microservices secure within the context they define? There's a bigger context, which is the context that they all live in. The more microservices we have, the more issues we're likely to see. So we've gone from building monoliths to mazes. So as an auditor or someone coming in to review the architecture or a system, it can be very difficult to understand the security promises, because no longer can we perform things like static analysis over a single executable. What we have now is a number of transitions, a network interface where processing is done, and that is much more difficult to understand and to reason about. And when we have autonomous teams, and when they have different goals, they will use different technologies. So my assumption is, people who are running microservices, you're using more than one set of technology. So you're probably not just the Spring Boot house. You're probably Spring and some Python and maybe some Go. And that makes it, again, more difficult, because no longer can we have rigorous policies to say this is how you must develop solutions, because actually it's changing. And we, as a security community, we need to be able to work with that. So I've spoken about it's difficult to analyze the interactions. And so we heard about this earlier, but the Facebook view as exploit is a classic one. So there's 3 bugs. And the interesting thing about this is it was the complex interaction between them that allowed there to be a vulnerability. And this is really hard to mitigate if you don't understand the system at this more holistic level and understand the interactions between your services. So we know it's hard to do this, and we know that the tools in this area are not as mature as perhaps if you're building more monolithic applications. Operationally, it's very difficult because security people are traditionally seen as mitigators of process, or progress rather, which is one of my favourite terms. And so we must work with organisations now to go faster. And the only way we can do that is to build tools. And this is why DevSecOps is cool, because we can build tools and get developers to use them. And we can move security earlier into the life cycle. So, with that being said, security for microservices is no different than security has ever been. There are 3 tenets of security which are the most fundamental: authentication, authorization, and accounting. Although the last one I prefer to call auditing, and I probably will call it auditing throughout the rest of the talk. So, at its most basic level, authentication is the identification of a human or a service. It is what we build access control on top of. It is the cornerstone of what we need to do. Authorization, who can do what, why, when, and where. Enough said. And accounting, what happened. So accounting is the one that generally gets left behind, but is as important now in security, and especially in microservices, as anything. So the ability to understand how big the exploit was, how big is my exposure to this exploit. Because once you've been exploited, it is very important that you understand what the impact is. It's no good just to say we've been exploited, because with GDPR, people are going to come and ask, how many records have you lost? So it's very important. And so what we're going to look at is how we can, in a microservices world, and with a security view of this, how can we make this easier? And the answer at the moment is becoming service meshes. So we're going to talk a bit about that, and specifically we're going to talk about Istio. Other ones do exist, otherwise to enforce these things do exist, but we're going to talk about Istio today because it is the de facto native Kubernetes service mesh. So, what does a meshless deployment look like? It looks like a childlike diagram on a PowerPoint slide. So, in a meshless deployment, users connect to your system, probably services deployed in containers, and each container enforces policy and does things in different ways, because we've got a Java container, we've got a Python container, we've got something else down here, and someone was mad and wrote a container using C. That makes it very difficult for us to reason about the security. Additionally, we may have third-party services in here, and they will have very, very different ways of enforcing policy and defining policy, so it makes it much more difficult. So what we're looking for is a way to bring this all together. And then we saw some talks earlier about instrumenting code and using frameworks and standards, but actually enforcing standards across larger organizations is very difficult, and it's not something we should strive to do. What we should strive for is a mesh network. So what is a service mesh? A service mesh is essentially an SDN. It's a software-defined network. It is at the deployment of your service, at the network level, so layer 4 to 7, there will be the injection of a sentry, a transparent proxy. But the difference here between, say, traditional API gateways, such as in AWS, is you will have a micro gateway per service, and they will automatically be injected every time you spin up a container or service. Now, at the point they're spun up, policy can be injected into them. And this policy defines how people are allowed, or services are allowed to interact with services that you're hosting inside your infrastructure. And here we can have people who set policy, and these can be teams, and teams can set policy as code. Okay, so it's quite an interesting concept, but it's all based on a software-defined network. Now, the nice thing about this model is scaling the policy and the gateway enforcement. So whilst with things like AWS's API gateway and various other versions that you can get from other cloud vendors, it's quite a large monolithic solution. This is far more fine-grained, and actually these are very lightweight containers, so they reduce the time and and maintain your throughput of your system, because they're actually looking at a small subset of rules just for your service or container. So in more detail, what is Istio? So Istio, as we've seen, is a software-defined network. It's split between a control plane and a data plane. The data plane is what sits in front of your service. Okay? It's built out of a component called the Envoy proxy, which came out of the company Lyft. Google and IBM and Pivotal and some other people have helped build this layer here, which is the control plane. And the control plane is what manages your security. So in the control plane is where we set our policy for our service. And this will be at the level of HTTP, and gRPC. So we can describe, this is my REST API, and these are the policies that apply to these endpoints. Or in gRPC terms, we can say these are the functions, and these are the people that are allowed to call these functions. You get some additional security measures, such as automatic TLS management, so that all your services automatically authenticate with all your other services without you having to do anything. You have no other solution there that you need to install. By default, all of your services will get an authentic TLS cert, which will allow service-to-service authentication. I guess the other interesting bit there to note is the telemetry part. So also built into Istio is the ability to monitor transparently all the requests that are going in and out of your system. And that can be hooked up to a number of other off-the-shelf solutions such as Prometheus. Bear with me. Here we go. Right, so let's go back to the 3 A's then: authentication, authorization, and accounting. They have not changed, we've just changed the architecture. So let's have a look a bit about what authentication means to a service mesh and modern web services. So authentication is, at its very basic, the unique identification of a human or service that's trying to access your system. How services and humans authenticate is slightly different, but generally it's a proof or a challenge which is swapped for a cryptographically signed token. So generally, I'm sure everybody in here is using JSON web tokens to various extents and hates them in various different ways, but they're quite simple to use. So if we look at how humans authenticate, it's generally through usernames and passwords, and obviously everyone in here uses a second factor, or not, but that you use these second factors and passwords to exchange your identity for a signed assertion. And that's the same whether you're using SAML or the newer authentication flows such as OpenID Connect. If you're building authentication going forwards, please choose OpenID Connect, not SAML. Your life will be much better. From a services point of view, it's not really changed. Services have an identifier and they have a shared secret or a public and private key, which they can use to exchange for an identity token. Additionally, there's things like mutual TLS, but we should probably try and steer away from that because it's harder to manage. So from the service mesh point of view, there's a pattern emerging. How do we enforce authentication for all our services without having to put the code into every single one and to audit to make sure every single one of our services is checking authentication has happened? And we can do that with transparent authentication. So transparent authentication works like this. The user tries to contact a service to perform an operation. Our Sentry, our service mesh, intercepts that request. Our service mesh can then, using the policy database, identify whether a request needs to be authenticated or not. By default, everything should be authenticated and that you should have a whitelist for things that don't. The important part there is the red line, because that is where the decision is made of who needs to authenticate. The service mesh then can say, this user is not authenticated, and redirect them to the correct authentication endpoint. What that does is it stops the service having to deal with authentication, and it means we can do authentication in a consistent way across all our microservices. And we've taken that logic up out of the application layer and into our network layer. The response from authenticating is generally a token, as we've said, and then when the user makes another request, the gateway can say, okay, does a token exist? Is it the correct token? Does it validate? If it does, request can go through. So what this does is it solves at a more holistic level how we authenticate and enforcing that policy for us. The next leg of our three-legged stool for security is authorization. So authorization is the decision of whether a user or service can perform an operation. So quite often people will take note of point 2 on this slide, which is, can somebody perform a request given some sort of context? And that will be time, policy, some other input. However, and when we look at the Facebook example, the third one down is actually more important now, because we can have services making requests on behalf of other services and other people. So there's actually, it's not just can service do this thing, it's can service A call service B, bearing in mind Alice, our user, has made the original request. So authorization can get quite difficult to manage. Now there's two types of authorization that we generally see in web services world, and certainly in the mesh world, what we think about. There's the explicit upfront authorization. So people who understand OAuth 2 or have had to deal with it understand that this means things like, how do I allow my CI engine to access my GitHub account to perform tasks on my behalf? And then there's the just-in-time aspect, which is, given an identity, can someone perform a task? So let's look at those in slightly more detail. So explicit authorization, as I say, is an OAuth 2-like model. And we see in the childlike picture to the side of the slide what this means. It means that a user or service will request from some authority an assertion that they're allowed to perform a task before they request it of our actual service. So this puts logic into the client that says, I must authorize before I try and access a service. Now this is really good. It works where you know there's a limited scope of authorization that your application needs before it goes to perform its tasks. And you can see here that our service mesh can check that given a token in a request, which has been previously issued, does that token include all the necessary claims that we're expecting to allow authorization to occur? So just-in-time authorization is slightly different and is slightly newer in some respects and is now being favored, and you'll see a lot of it in the Google stack. This is where, instead of a user requiring an upfront decision about whether they can access a service or not, based on their identity, the service mesh will make a just-in-time decision. So assuming a user is authenticated previously, as we saw on a previous slide, they will provide their identity token each time they make a request. What the service mesh Sentry can then do is say, can this person perform the task they're asking at this time? And what that allows you to do is build far more dynamic authorization models and also allow far more entropy in your decisions, because you don't have to allow or enforce upfront decisions. So you just base it on identity and the current context that can be identified. So they're two slightly different models, but it's quite interesting and to understand the two and where you might want to use them. So if we compare them, we see that explicit authorization is a really useful thing when we are asking an external entity whether we can perform a task or whether we're trying to allow a service to perform on our behalf. Where just-in-time authorization is useful is when we've got far more dynamic context and where perhaps our application or client doesn't know the scope of the authorization it will need throughout its lifetime. Both are valid approaches, but they're subtly different in where you might want to apply them. So the final A in our 3 A's is accounting or auditing. So accounting is what's been done and why. This is the bit that's always missing from whenever you go and see vendors. They will set up an audit trail, but it'll just go into a bucket and never be seen again. But actually, that information is really useful. You can use it to feed back into your pipeline for authorization decisions because it allows you to identify things like anomalies. Additionally, you need to keep on top of it in case you ever do get breached. It's fairly simple to understand, but when we look at it from a service mesh point of view, it's something that happens during the authorization and authentication schemes. It automatically falls out what you're doing. So when a request comes in, the service gateway identifies the authorization and will create your audit record for you automatically. So again, this is quite nice because this offloads a lot of this logic from the application and allows us to centralize and normalize this at the layer 7 of the network stack. So Istio supports, or will support in the next 2 releases, all of these functions. But the real interesting part is how Istio is configured. It is configured as code, so it becomes source code. So it becomes really useful and much more easy for our devs to use in their workflow because they can use the normal tools they always use. They can review the policy that they define for their microservices. They can understand the rest of the system because they can see the rest of the system's policy definition. And we can manage it with normal tools. So I don't know if anybody's seen Weaveworks GitOps talks. Has anyone seen those? If not, you should watch them if people haven't seen those. Really interesting, where you control your whole life cycle through Git and Git commits. Absolutely fantastic. But the other really interesting thing, I think, the next stage of everything will be the fact that these policies are parsable. And what that means is we can build tooling for them. And so when we look back again at the Facebook examples, Facebook was difficult to identify and to manage their exploit because it was difficult to see the interactions with their system. Because in Istio and other frameworks, we can define all of our policy as code, we can actually enumerate all the possible scenarios. And so we can identify anomalies up front just by the configuration that's going into the database for our policy store. So that's a really powerful thing that's coming along and will probably be here in the next few months. Config as code as well helps us to define what our system is and what it is doing and helps others to understand it. So it allows developers to document on the go in a very lightweight fashion without forcing them into writing separate design documents or adding comments in their code, which are then having to be passed by complex tools. It's just a really good and nice way to help us manage security. The other thing that we get with these service meshes is observability. And what that really gives us as a security community is the ability to reason about our system and to make macro-level decisions. So are we vulnerable to certain attacks? It's much easier to identify that if we can observe the behavior of the running system. Okay? And it allows us to self-document our system and save time. And these are the really interesting points of the service mesh. It's not so much how they're built, but the capabilities they will give us in future. So everyone loves reading YAML on a PowerPoint slide. So I thought I'd show you an example of an authorization policy for Istio. So there's 2 concepts shown here. Istio works on an RBAC model, so role-based access control. The 2 YAML entries at the top define roles. So the one at the top, an admin role. The admin role can do everything with all services, which is probably quite open. You probably wouldn't want an admin role quite like that. But the second one's more interesting. So the second one identifies a single service and the methods, the HTTP methods that are allowed to be executed on it. And so it's specific to this service. Now this bottom section of the configuration here defines what is called a role binding. So the role binding binds a role to a set of principals, a set of people, a set of services who can perform that role. So we can see here that there's a number of subjects listed, and we have user account, service account A, and also user service account ingress, which also has properties with claims in. So these claims actually come from a JWT passed by the user onto this service. And so what this means is that we can say, through this service, this user is allowed to perform the tasks defined in this role. So what that gives us is much greater control over who can do what, when, and why. And because it's YAML, we can parse it, we can build tools, and we can reason about it. So, that was quick. My final slide is really about the move towards microservices and autonomous teams has presented a conundrum for us, because previously, whilst there would be big gates, especially in big companies, big gates in place to do security reviews, to verify people are doing things in a consistent way, that's no longer possible, and it shouldn't be how we're looking to build our systems in future. What that does mean is we have impaired view of our system from a security perspective, and it makes it very difficult for us to reason. By moving towards a service mesh, we can normalize some of this decision making up a level out of the applications, and we can then self-document and understand our system better. The config as code bit, I think, is the real takeaway from the whole, and certainly my involvement with the Istio community. This is where all the power comes, because once you start managing your entire estate, infrastructure, policy, source code, everything is code. Everything's a text file that you can parse. You can start to build really powerful tools and understand a lot more about your system. So that, if you're going to take one thing away from this whole talk, is move in that direction if you haven't already, and find tools that fit that model. So that was mostly what I was going to say today. There's various links there which may or may not be interesting. If anybody's interested in Istio, please come and talk to me. Otherwise, thank you very much. Questions, I guess. Silence. Is there one? There's one back there.
Hello. Any thoughts? Hello. Any thoughts about how to get the config as code as close as possible to the application that you might be writing on the microservice, or does it end up in a different repo?
No. So I can only talk about how we're building our internal microservices. Is that with our Kubernetes deployments and our source code for a service, they all live together, including the policy definition. So whilst the role binding doesn't live there, so who can access what, because that might change because we build products, not services, we keep it all together and keep it all in one place. So what that means is we can review everything together in one source commit. We can verify that the policy matches the code that we've written and whether it all makes sense. And it also means it's far easier to manage from a source code perspective because there's a single Git commit. Instead of having separate repositories and then having to bring separate repositories together, we put everything with the service. So the policy lives with the service. Oh.
Yeah, most of the thing what you're talking about is not taking, is it not taken care in the API manager like a WSO2 or the RPG and other stuff?
Sorry, can you repeat that?
No, most of the thing what you're talking about, isn't it taken care in the WSO2 API manager?
So from an API gateway, external calls into your system are generally stopped at the API gateway. What this covers is internal calls as well. So generally, you wouldn't internally go out through an API gateway and back in. So that, and this again is about using container native tools. And so you can supply very fine-grained policies at the point at where they're going to, or as close to where they're going to be enforced without actually having to make code changes. And especially if you've got a heterogeneous environment where you've got lots of different languages, it's just a way to manage that. Anything else?
I think I might be the only person here that actually works on a Microsoft stack, because everyone else is talking about Java and those sorts of things. But so we're predominantly using Azure, and I just wanted to know from your experience, I don't know what experience you have particularly with Azure, but Azure uses a technology called Service Fabric in order to orchestrate its microservices. What is the difference between the two?
I don't know anything about Service Fabric, and I've never logged into my Azure account.
Okay, well,
If that's helpful. Sorry.
okay.
So
No,
my expectation is with Kubernetes moving into Azure, which I know is happening, you will end up with Istio or an equivalent in there that does the same thing. I don't know what level Service Fabric applies, but Istio is really about embedding in Kubernetes, or if you use Pivotal Cloud Foundry, Istio is turning up there as well. So Pivotal are a big proponent of Istio.
I assume the one big advantage as well would be, as you say, this is kind of language and stack agnostic in terms of if you want to go Python, Go, Java, etc. You can orchestrate that as
Exactly, and that's part of the reason that we've selected it, and actually why we are contributing back to the open source is we understand we're going to have this heterogeneous environment where we don't really want I think we've got about 25 Scrum teams, we don't want to tell them to use, you must use Java and Spring Boot, because no one actually likes Java and Spring Boot. But we want them to make the right decision based on what they're trying to achieve. This is just a way to allow us to normalize certain decisions.
okay. Thank you.
Oh, there's one there.
Hey, just a question about Istio. I know you mentioned during the talk that there's a couple of features that were coming soon, perhaps, and at the beginning when there was a show of hands of who's using it in production, I mean, maybe I'm too close to the front, but I couldn't see many from where I am.
No,
how mature is it? Is it something which is ready to be rolled out in the production
Istio
environment?
hit 1.0 about 3 months ago, so it's available. A managed version is available on GCP, so Google, but it has literally just reached 1.0, so it's very early stage. But the APIs, existing APIs, are deemed stable, and it is deemed production quality. So it is used by people like Google internally. I think that's it.